All right, geometry folks. Let's do a little geometry. How about that? Here's a warm-up for you. Give this video a pause and try it. All right, let's hope you tried it. Number one, we have a right triangle. We know one side length. We want to know another side length, and we have an angle measure. And so it looks to me like we can definitely find the value of x in this one because we have this wonderful tool called trigonometry. First, we identify theta. Then across from theta is our opposite side. Across from the right angle is our hypotenuse, leaving the other side to be the adjacent side. And now that we have our triangle labeled, we can remember that we have to figure out what we have and what we want. What we have is h, what we want is a, and that is going to help us find the correct trig ratio out of the three trig ratios, sine, cosine, and tangent, and we can remember them by remembering SO, CA, TOA. So we need to find the one that has both an A and an H in it, and that is the cosine. And so sine and tangent are not useful, and we're going to use CA to set up an equation. And this is trying to tell us that the cosine of the angle is the adjacent over the hypotenuse. Done. Now we're going to take cos 57 and plug it into a calculator. In my calculator, I have to put in the 57 first and then press cos. It may be on your calculator that you put in cos 57, so be careful with that. 0.54 is the value of cos of 57, and that equals x over 10. Now to clear that 10 out of the denominator, I'm going to multiply by 10 on both sides. 10 times 0.54 is 5.4, and these cancel, so that equals x, and we have solved for x. The second question, can you find the value of theta in this triangle? If so, do it. If not, what do you need? Well, the answer to that question is no, because even though we've got an angle and sides, we don't know how to find an angle from sides yet. We could find the measure of this third side by plugging 22 and 57 into the Pythagorean theorem. We could find that's about all we can find, actually. So the answer to this one is no. But by the end of this, your answer is going to be yep. So it's time to update that notebook. Pause this video, do your updates, and then come on back. Today's topic, inverse trigonometric functions. How can you find angle measures if you know side lengths? This is your essential question. So far, we have used trigonometry to find the length of a side of a right triangle when we know the length of one side and the measure of one angle. So for example, we can find the length of r by recognizing that we have a theta, and directly across from theta is the opposite side. Directly across from the right angle is the hypotenuse, leaving this side to be the adjacent. We know the adjacent, we want the hypotenuse, and that's going to help us pick a trig ratio. We have SO, CA, TOA to help us remember how to set up those equations. We have the A, we want the H, and so the cosine again is the one that's going to be most useful to us. And then we say that the cosine of the angle is the adjacent over the hypotenuse. And then we solve from there. On my calculator, I'm going to plug in 41 cos, and I get 0.75. And that's going to equal 15 over r. And then multiplying both sides by what's in the denominator always gives us 0.75 r equals 15. Dividing both sides by 0.75, sorry, cancels these here, leaving r by itself. So we have 15 divided by 0.75, and that is 30. Done. That's not right. 15 divided by 0.75, 20. It's 20. All right. Got it? So That's how you do it. That's trig. We've been doing trig a bunch. The steps are the same. Identify your sides, figure out what you have and what you want. Use that to pick a trig ratio, then use that trig ratio memory device to build an equation, and then solve the equation. And what we're about to do next only changes a little bit of that. Because we can use trigonometry to find the measure of an angle if all you know are the lengths of two sides. So again, there's a couple of ways to do this. First, with calculators. The labeling of the buttons you need is going to be slightly different depending on the type of calculator you have. But on the calculator you have, you should be able to find the sin, cos, and tan buttons, the sine, cosine, and tangent buttons. Now you know what they're for. Now right above those buttons, there is some more writing. There's either sine to the -1, cos to the -1, and tan to the -1, but they might also say a cos, a sine, a tan, or maybe even cos, sin h, and tan h. Those all mean the same thing, and these buttons calculate inverse trig ratios. And what these do is help you find the measure of angles when you know side lengths, and I'll show you how in just a second. Again, on my phone, I had to turn it sideways, and then I had to hold down the sin, cos, or tan buttons to get those inverse buttons, but it's on my phone as well. No matter what, though, your calculator has to be in degree mode, just like with regular trig. So, of course, you can also look up this stuff on a table. You're going to use them like you did before for finding side lengths, but now you're just going to use them backwards. These charts are in Google Classroom, so you can use them if you want to, and here's what they look like. Before, what we wanted to know was maybe the cosine of an angle, maybe we wanted the cosine of a 16-degree angle, and so we looked up the 16-degree angle, and then we looked up the number for cosine. And we're going to do something similar to that now, but now we'll have a number, and we'll have to look up the corresponding angle. So it would be in backwards order. You'll see how it goes as we move forward. So here are the steps for finding an angle measure if you have two side lengths of a right triangle. Notice what you know about the right triangle is two side lengths, and you want to find an angle measure. Next, you're going to identify the sides. Then you're going to notice the sides that you have, and you're going to use these to set up your equation. Then you're going to pick the correct trig ratio based on what you have. Then you're going to use SOHCAHTOA to help you set up an equation, and then solve using your calculator in degree mode or look it up on the table. Are these steps familiar to you? They should be, because they're almost exactly the same steps that you use to solve a trig problem, a regular trig ratios problem, except there's slight differences, and we'll see those differences as we work through a problem. So the steps are to first notice that what you know about a right triangle is two side lengths, and you want to find an angle measure. And in this particular problem, that's exactly what we have. We've got two side lengths of a right triangle, and what we don't know is this angle measure. Now, a couple of you actually will be able to guess that angle measure just by looking at the relationship of those sides, but I'm going to leave that for you to think about. So we've done our noticing. Then it says to identify the sides. Well, you're going to do that just like you did it before. Here's theta. That's the angle, you're trying to find. And across from theta is the opposite. Across from the 90-degree angle is the hypotenuse, and the other side is the adjacent. Label your sides just like before. Now, before it was notice what you have and what you want, but now we're just going to notice the sides that we have. We have the O, and we have the H. We don't care about the adjacent side in this particular problem because we don't have any information on it. Now, we're going to pick the correct trig ratio based on what we have. Remember, there are three, and we can remember them by remembering SO, CA, TOA. Now, we have the O, and we also have the H, and the sine ratio is the one that gives us information on that, and so these two are not handy. So, now we're going to use SO to help us set up the equation. And this literally says the sine of the angle is the opposite over the hypotenuse. And so we're still going to do that. But now we have the sine of the angle, which we don't know. In this case, it's marked with a question mark, is the opposite, 9, over the hypotenuse, 18. You're still using that sentence to pull those pieces into the right space. The sine of the angle is the opposite over the hypotenuse. It works like that every time. Okay. So this looks different, right? Because really the last step is what it's always been, solve using your calculator in degree mode or look it up in the table, but we've never solved an equation where the variable was the angle. So I'm going to show you how you do this. The first step is to simplify your fraction, this one right here. And that's just going to be a matter of plugging it into your calculator. So on the left side, we're still going to have sine of question mark equals, and then 9 divided by 18, which is 0.5. Okay, so all we did was simplify that fraction into a decimal. Now we could do one of two things. We could use our calculator, or we could look this up on a table. Let's look it up on a table, because what we want to find is somewhere in the sine column the number 0.5, which will give us the angle that we're working with. So let's see. When I'm looking through the sine column, notice how they're getting bigger. Here's 0.43, 45, 46, 48. Oh, here's 0.5, and that's a 30-degree angle. And so what we know is that question mark equals 30 degrees, and that's done. Yay. Yay for trig tables. Now, what if you didn't have your trig table handy? Well, we can still solve this, and that's going to use those different calculator buttons that we talked about just a minute ago. So what you're trying to do is you're trying to get this variable by itself, and so what you kind of want to do is get rid of this. You want it to, quote unquote, cancel, and there's a function for that. It looks like this, or maybe it looks like a sine or a SINH, but it's that button that's right above the sine button on your calculator. My calculator has a sine to the -1, and that is the most common. So anyway, what that button does, if you multiply it essentially by the sine, is that it cancels it. So what you're going to do is you're going to multiply, quote unquote, by the inverse sine on both sides. So the inverse sine times sine of question mark equals the inverse sine of 0.5. This creates that cancellation right there, which is why we're doing it. We're just, quote unquote, multiplying on both sides by the inverse trig ratio. What's left is the question mark. And then what you have to plug into your calculator is this. And so in my calculator, I'd have to put in 0.5 and then second sine. And it gives me 30. On your calculator, you might have to do second sine and then 0.5. But no matter what, you're going to get 30 because this is a 30-degree angle. Now, the reason why some people knew that already is because this right here is the short side. And if you take that 9 and multiply it by 2, you get 18. And that's how 30, 60, 90 triangles work. But you can also figure it out by using inverse trig ratios. All right, let's do it again so you can see it again. So notice what you have in a right triangle is 2 side lengths, and you want to find an angle measure. So here's a side length, here's a side length, and we do not know theta. So we're going to identify the sides just like we did before. Across from theta is the opposite. Across from the right angle is the hypotenuse, which leaves this one to be the adjacent. We've identified the sides. Now notice the sides we have. So we have the opposite and we have the adjacent. And so that's going to help us set up our trig ratio. We're going to pick the correct trig ratio out of sine, cosine, and tangent. Remember, sine was so, and then we have ca, and then we have toa, and one of these has O and A in it. Those are the sides we have the lengths of. O and A are inside the tan, and so those aren't useful. Now we're going to use toa to help us set up the equation. Well, we know that the tangent of the angle is the opposite over the adjacent. And now we've got an equation to solve. First step is to take care of that fraction. So we have tan of theta over here equals 27 divided by 52, which is 0.038. Okay? Now we could go to the trig tables and we can look up the measure of that angle. We can go down the tangent and look for 0.038. So let's see. Wait, what was it? 0.038. Tangent, 0.0349. Uh-oh, 0.0524. It looks like maybe we've got something a little bit in between. So the trig table for the first time is not super helpful, or maybe I've done something wrong. 27. What was it? Oops. Divided by 52. Yeah, see, I did something wrong. Sorry. It's not 0.038. It is 0.519. A little better. 27 divided by 52 is 0.519. So now let's go to the trig tables. Is there a 0.519 in the tangent? Oh, look, it's close here, but we're still not there yet because it jumps from 0.50 to 0.53. So it looks like we're going to have to use that button. It's going to happen sometimes, so that's all right. Okay, so essentially what we're going to do is we are going to solve using our calculator in degree mode, because looking it up on the table was a little bit problematic. We couldn't find 0.519 on the table, but that's okay, because all we have to do is use the inverse tan function to quote-unquote cancel tan from the left side. In other words, the tan inverse of tan theta equals the tan inverse of I didn't give myself enough room. Can I drag this down a little bit? Yeah. Of 0.519. This tan inverse cancels that tan, and what we have on this side is theta, and then we plug into our calculators 0.519 second tan. And it's a 27.42 degree angle. And the reason why we weren't able to find it on the table was because it's somewhere between 27 and 28 degrees. Let's see if that's right. Between 27 and 28 degrees. Look at that. We've found it right. It's going to be right in here, which is right between 27 and 28 degrees. So it just didn't appear on the table. But we can still calculate it because we have the tan inverse buttons. All right, let's do one more. First of all, we have to notice that we have a right triangle. We know two sides, and what we want to find is an angle. The next thing to do is to identify our sides. And so here's theta. So across from theta is our opposite. Across from our 90-degree angle is our hypotenuse, leaving this side to be the adjacent. We know information about the adjacent side and the hypotenuse, and we're going to use that to pick the correct trig ratio. There's so, ca, toa to help us pick the right one and to build an equation. We know about the a and the h, and so it looks like we're going to use the cosine ratio. This is basically the same steps as you did with trigonometry problems. Now, the cosine of the angle is the adjacent over the hypotenuse. And now you've got an equation to solve. The first step is to take care of 13 divided by 25. So the cosine of the angle is 13 divided by, let me make sure I do it right this time, 13 divided by 25, 0.52. Now we can go to the trig tables and see if we can find 0.52 in the cosine list. Where are you? Let's see, cosines. They're starting here at 0.89, so maybe we need to go one more back. 0.52 in cosine. 0.52, there's 0.51, there's 0.5299, so it looks like we are needing an angle that's going to be somewhere between 58 and 59 degrees. Let's use our cosine button instead. Since it wasn't exactly on the tables, let's use that cosine inverse. Well, we know that the cosine inverse of, every time, of the cosine of theta equals the cosine inverse of 0.52. We're just, quote unquote, multiplying on both sides by cos inverse. The reason why we do that is because it cancels these guys here, and what we have left is the angle, which is what we're trying to find. And then we can push into our calculator the cos inverse of 0.52. On my calculator, I have to put in the number first, 0.52, and then second cos. And I get 58.66 degrees, which is exactly what we kind of thought when we looked it up on the table. So these steps are a little bit different than when you were doing regular trigonometry, but the differences are not that big a deal. It's just kind of getting used to this inverse stuff. But once you do, you'll find that you're able to find angle measures when you have side lengths. All right, y'all, your practice is on quizzes. It's not a quiz. I hope you have a wonderful day, and I will see you next time. Bye.